A bridge usually has two ports. Bridges are not used anymore. They have also been replaced by switches. Now let's take a look at switches. Think of a switch as a hub and bridge rolled into one. It connects the devices together, but it can also learn which ports connect to which hosts. Let's see how this works. A switch has something called a MAC address table. This table will list each MAC address and which port is connected to. In this example, host A will send some data to host C. The switch receives the data, but as you can see, the MAC address table is empty. The switch in this case will forward the data out of each port just like a hub. Unlike a hub, the switch now learns host A's MAC address.
So, what is the name given to this Good. MAC address. Let's continue.
Can be reached on port 1. And when host C sends data back to host A, the switch knows exactly where to send the data. Now if you notice, the switch has learned that host C's MAC address can be found on port 3. Using this process, very quickly the switch can learn how to reach each host connected to it. Let's review. A switch is a layer 2 device. Like the bridge, it can learn MAC addresses, which are known as layer 2 addresses. A switch can use full duplex, meaning it can send and receive data at the same time.
A switch and
This means each port has its own position domain. This is a huge improvement
there are some
over
differences between what?
because it can learn MAC addresses. A switch saves huge amounts of bandwidth, and now because only the destination host will receive the data, other hosts can't see it.
There is some kind of difference between what?
Routers. You can think of routers as the doorway out of your internal network and into the outside world. To understand what routers do, let's take a familiar example. Let's say this is your home computer, this is your switch, and this is your router. Now just on a side note, usually a home router has the switch built in, but in an enterprise network, they're separate devices.
What is the name of this device? Router. It's called what? It's called what? And this is what? Or what? Switch.
So on the other side of the router, you have the internet. Let's say you send an email or visit a website to a computer.
It means that you guys are flowing. Yes.
You will send data to the router using its IP address. The router will then forward the traffic out of your home network and into the wonderful world of the internet. When data comes back, the router will forward the data back to your
If you watch the next video, then we do our exercise, okay?
Yes.
A router is the way out of your internal network. A router uses not only MAC addresses, but also IP addresses, which means a router is a layer 3 device, because IP addresses are known as layer 3 addresses. It usually has 2 ports. A router is highly configurable and has many, many different features that are beyond the scope of this video. That's it for basic network devices. You've learned about the older hubs and bridges, and also the modern standard of switches and routers. I hope you've enjoyed this video. If you did, don't forget to subscribe, leave a comment, and give a thumbs up. Thank you for watching.
Learn valuable business and IT skills in your own time and at your own pace with HP Life, a free online skills training program. HP Life is...
Welcome to Silk Pros. In this video, we're going to be taking a look at the OSI model. So, what is the OSI model?
Who can tell us? What is the OSI model? learned all these things, so informal, right? So after the video, in our next class, I'll give you a detailed notes on starting from computer networks, the devices, then the OSI modules. Then we talk about the types of networks. Okay?
The model is a theoretical stack of 7 layers that can be used as a reference to help understand how networks operate.
I know that as we move on,
The model was
you
introduced
get to know that you've learned all these things, but move down to the
to standardize networks in a way that allowed multi-vendor systems. Prior to this, you would only be able to have a one-vendor network because the devices from one vendor couldn't communicate with others. It's worth noting at this point that we don't actually use the OSI model. We use something called the TCP IP model. The concepts are exactly the same, the layers are slightly different. So if we don't use the OSI model, why would we bother learning it? Well, that's because it's still referenced a lot when troubleshooting or describing network operations. Let's take a look at the layers starting from the bottom up. Layer 1 is the physical layer. The physical layer is the lowest layer of the OSI model. Its key responsibility is to carry the data across physical hardware such as Ethernet cables. Layer 2 is the data link layer. At this layer, the physical addresses are added to the data. This is the source and destination MAC addresses. Switches are located at this layer. The network layer handles IP addressing and routing. At this stage of the OSI model, the source and destination IP address are added. Routers operate on this layer. Layer 4, the transport. The transport layer of the OSI model adds the transport protocols such as TCP and UDP. TCP, for example, is used for error handling and sequencing to ensure no data is lost. This layer also adds the source and destination port numbers. Layer 5, session. This layer is responsible for establishing and terminating connections between devices. Layer 6, presentation. This layer formats the data in a way the receiving application can understand it. This layer is also able to encrypt and decrypt data if needed.
So guys, haven't you heard about the physical layer? Do you have them in your notebooks? So you didn't include the OSI models? Okay, so I'll give you a note on that, okay? Let's continue with our video.
Layer 7, application. This layer is where the application and user
So from the video, you can see that at the physical layer, this is what happens at the physical layer. Then we're going to move on to the second layer. It's called what? Data link layer. What do you have here? And what? What is the third layer? Network was layer. And what happens here? You have the IP address. It's not router, it's called router. What's the next layer? You have the TCPs, you have the UDPs, you have the port numbers. What's the fifth layer? Session.
Application.
So as time goes on, these layers will become what? 5 layers. So the presentation, the session layer will be what? Off. So we have layer 1, layer 2, layer 3, layer 4, and layer 5, which is what? The application layer. As you go for the university level, the university level. But as it stands now, we have for how many layers?
7 layers.
And what's the first layer?
Physical.
The second layer? Third layer?
Network.
The fourth layer?
Transport.
The fifth layer?
Session.
Cease.
Presentation.
The last one is what?
Application.
Let's continue.
Application-specific protocols are used here, such as SMTP, if you're sending an email, for example. A really good way to remember these layers is simply all people seem to need data processing. APSTNDP. So to fully understand how this model works, you need to see a real-world example. Let's say you send an email. The data travels through the OSI model, adding and processing data on each layer. And this process is called encapsulation. Step 1, the application layer. Outlook creates the data, the email you wrote, the email addresses, etc., etc., and gets ready to send it using SMTP, which is the Simple Mail Transfer Protocol. Step 2, presentation layer. The data is formatted in a way the receiving device will understand. In this example, probably ASCII. This layer could also encrypt data if needed. Step 3, session layer. A session with receiving mail server is started. Step 4, transport. This is where it decides to use TCP or UDP. In this case, we'll use TCP to make sure every packet gets delivered. Also, the source and destination port is added to the data. Step 5, network. The IP address of the mail server is added as the destination, and the source IP address is also added to the data. Step 6, data link. The MAC address of the router and the source MAC address of the host is added to the data. Step 7, physical. The data is sent out on the network using Ethernet. So when the data reaches the other side, the receiving device will process the data in the same way but in reverse, starting from the bottom up. Okay, so that's the OSI model. But how can we use this to troubleshoot? You may have heard the term, oh, that's a layer 2 problem.
What's the word in the board?
Troubleshooting.
Good.
Or sounds like a layer 3 issue. When you hear that, that's people referring to this model. Let's say there's a problem with the network. If we go through this model, check every layer, we can soon diagnose the problem. For example, layer 1. Are all the cables plugged in? Is the network card functioning? Could it be a faulty cable? Layer 2. Maybe the switch has gone bad. Layer 3. Is the router functioning? Do I have the right IP address? And the process goes on and on from there. I hope you've enjoyed this video. If you have, remember to subscribe, comment, and give a thumbs up.
So,
Thank you for watching.
we are done watching the third video. We are going to take our exercise. There are so many videos that you will be watching. This is what you
My name is David. Some thoughts about myself. I've been to
Hey, what's up, guys? Welcome to Cerberus.
have so many videos. go through the notes that you've made before we do the exercise. I'm giving you 2 minutes.